Now that we have those S expression values and operations, we can look at parse again. And this is parse without the star because we don't need a hook anymore. We're going to add let macro as a form within our language. So parse just matches on let macro, some symbol on right hand side, and then the body of the let macro. When we run a program that has let macro, the macros go away because we're interested in the expanded parts here. This part here might have references to that symbol that need to be expanded away, but at the end, the let macro doesn't contribute anything. So ultimately, parse is just returning the parse of the third part here, which is that any right there, the body. But as we're expanding that, then again, that might refer to one of the symbols here. So we've got B's here is the list containing symbol and any. And the point of let macro is that if we have a reference in any to that particular symbol, then we need to apply this expand function here. The problem is that parse is just so far getting that body expression and nothing about the symbol. We will need a way when we find a symbol to look up how it should expand. So that's the symbol that we need to recognize. We need to pass it to parse somehow. And we've seen this kind of thing before. What we want is an environment. So I'm changing it to parse star after all, but this time we're passing along an environment and instead of an extension hook. And when we call parse star for the body of let macro, then we're going to pass an environment that maps this particular symbol to something. And that way, as we'll see later, our parser is going to be able to recognize this symbol and trigger the expansion function. Now the expansion function over here, that is an expression. So we can parse that expression. And after we parse that expression, we could just interpret. So something unusual is happening here. Our parser is calling our interp function. And up until now, that has been disallowed. The whole job of parse is to get to an abstract syntax tree where you can interpret it. But the reason that it's happening now is because this parse time interp, or I might say compile time interp, is completely separate from the runtime interp. Notice that we start it with an empty environment. That's saying that this expression over here is not allowed to refer to any of the runtime variables that we might have declared in the surrounding context. Instead, as we parse, we have to keep running these little programs, which are the expander function programs. So the result of those little programs are functions that we bind to symbols in this parse time environment. And then we use that parse time environment when we find a curly brace and then anything followed by any number of anythings. This could be a function call, or maybe now it's a macro use. Maybe this first any is actually a symbol that refers to something in our environment. So let's pull that symbol out and we'll call it Raider because it's in the operator position. Now this Raider might be an identifier or it might be something else. If it's something else, or if it's an identifier that's not in our environment, then it's just a regular application form, and so we're going to try parsing it as a macro. But if that fails for any reason, then we'll just make sure that there are exactly two things, because we have only single argument functions, and parse it as an application. But the thing we will try is that we will take that operator, turn it into a symbol, and then look it up in our parse time environment. And if looking it up fails, then the try goes to this lambda and we parse it as an application form. But if it succeeds, then that will be a function. And we want to apply that transformer function as a macro to the S expression that's what we came in. So our macro function is going to get the whole S expression, and then it's going to rewrite it to some other expression. And then we should try parsing that again in the same environment. Finally, the apply macro function takes a transformer, which we expect to be a closure, and an S expression to produce the expanded S expression from that transformer. So it just makes sure that the transformer is a closure. And then we want to apply the closure, that is, interp the body of the closure, using an environment that's extended where we take the S expression that we currently have, turn it into a value so that we can interp with it, bind it in the environment, call the function, and what we get back will be a value that we can turn back into a PLAI typed S expression and continue parsing from the result of apply macro. So using this macro extensible language, we can write delay in force like this, so that we have force of delay of 7, we should get 7 back. The way it works is that delay of 7 triggers this macro transformer, which receives delay of 7 as an S expression, S, and then it's going to cons on a lambda and a dummy variable in curly braces, and then use the second part of s, that is the first of the rest, as the body of the lambda. That's what delay does. It wraps it in a lambda. Force takes its argument, and which is the first of rest of s, and applies it to some dummy argument 0. So when we run this, we'll get that force of delay 7 is 7. We can see that implementation in let macro. So again, it has the parse star here, which takes an environment. Let macro extends that environment. And our general form here tries to parse it as a macro. And then finally in our test cases, we have here, for example, let macro m takes an s expression and just returns the s expression 10. So parsing this whole form just produces the same thing as parsing 10 by itself, because this macro m is triggered and it just returns 10 to replace the curly brace m. As a more interesting example, we want the let form. So the let form is complicated just because there's a lot of pulling pieces out, but we have this testing function add let, which takes an s expression and wraps around it let macro let with the implementation of let, and then s is the body. So by using add let, for example here, then we're adding the let macro binding so that we can do a parse and interp of an expression that uses let to make sure that let works. And we have several examples of add let then. We can also try our delay and force example here, where we have let macro delay and force, and make sure that it expands to a program that when we run it produces the value 7.